Today I'm going to be talking about how to write a solution function y of t in terms of a single sine function and a single cosine function. And I'll be using y of t equals 7 sine of 2t plus 6 cosine of 2t. So the first thing that we're going to have to realize here is that when we write it in terms of a cosine function, we're going to end up with the form a cosine of omega t minus delta. A is equal to the amplitude of the function, omega is equal to the angle, and delta, we're going to find delta by taking the arctangent of C1 and C2, and if you look to the bottom of the screen there, you'll see that C1 is equal to 7 and C2 is equal to 6. And when we write this in terms of a sine function, we're going to write it very similarly to a cosine function. It'll be a sine of omega t minus delta, and then we're going to add a phase shift to compensate for the horizontal shift that makes the difference between sine and cosine. So, as I said earlier, we're going to be using C1 is equal to 7 and C2 is equal to 6, and we find those C1 equals 7, we would have the C1 here in a general solution, and a C2 would be here in a general solution. So we're going to set up the Pythagorean theorem using the right triangle, and we have delta here, phi there, a, C1 equal to 7, and C2 equal to 6. We can get a by saying a squared is equal to 7 squared plus c squared, which means that a is equal to the square root of 7 squared plus c squared, which is equal to a equals the square root of 49 plus 36, which is equal to a equals the square root of 85, which I approximated to be 9.22. Now we're going to put all of these in the form a cosine of omega t minus delta, where our omega stays the same. It is 2. The amplitude is equal to 9.22, and delta, as I said earlier, is going to be the arctangent of 7 over 6. We take the adjacent and divide that by the opposite with respect to delta, and that gives us the form y of t equals 9.22 times cosine of 2t, that is a minus sign, of 0.86217. So we have y of t equals 9.22 cosine of 2t minus 0.86217. Now, if we want to write this in terms of a sine function, we can do that very easily now that we've found the cosine function. As I said earlier, sine and cosine are essentially the same function, except there is a phase shift, and we see that right here. Cosine of x is equal to sine of x plus the phase shift of pi over 2 inside the parentheses here. And since by this form here we have a sine of omega t minus delta plus the phase shift, we also have a cosine of omega t minus delta. So, in order to write the sine function, we can take the same properties from the cosine function, substitute them in here. We have a equals 9.22, omega equals 2. We have the inverse tangent of 7 over 6. But notice here now we have a sine instead of a cosine, and so to compensate for that, we're going to add the phase shift of plus pi over 2 down here. And that'll make everything equal. So we have the original function, y of t equals 7 sine of 2t plus 6 cosine of 2t, which we said was equal to 9.22 cosine of 2t minus 0.6217, And when we wrote that in terms of a single sine function, we got 9.22 sine of 2t minus 0.86217 plus pi over 2. I hope this helps. Happy mathing.